In the retrofit world, we often see two extremes. On one end, you've got weather stripping, caulking, and foam gaskets. It's cheap, but it barely moves the needle. On the other end, you've got deep energy retrofits. Strip the cladding or gut the interior. It works, but it costs a fortune and displaces tenants for months. The industry needs a middle option, a scalable way to achieve high performance without the gut renovation. In this project that's funded by the Peter Gilligan Foundation, the Federation of Canadian Municipalities, and Enbridge, we set out to prove that a middle way exists. We take a process-oriented approach that combines targeted manual sealing with AeroBarrier technology. And we didn't just guess at the results. We brought in Building Knowledge Canada to provide independent measurement and verification. So here's the exact process we followed to achieve ENERGY STAR performance on existing townhomes that belong to Chatham Hope, a social housing operator.
Before we get to the how, we need to answer the why. Why go through this effort to seal an existing building? First, it's about energy. In a leaky home, you are paying to heat or cool the outdoors. By sealing the envelope, we reduce the load on your mechanical systems and lower utility bills instantly. Second is comfort and health. We aren't just stopping heat loss, we are stopping drafts, dust, bugs, and pollen. And for multi-unit housing like this, it's about compartmentalization. Effective air sealing stops the transfer of cooking odors, smoke, and even noise from your neighbors. Creates a private, healthy sanctuary for the tenant, which is the ultimate goal of social housing. So how do we get there? Step one is the test in. You can't manage what you don't measure. We start by measuring the CFM. This gives us a baseline measurement of air leakage to compare against later. We use the blower door and a fogging machine to investigate the major sources of leakage. In multi-unit housing like this, once you find the failure points in one unit, they tend to be identical across the whole block. Hiring an experienced energy advisor here is non-negotiable. It's a small investment that validates every dollar you spend afterward. Step two is safety. You shouldn't make a building airtight without replacing combustion appliances that source their air from indoors. If you tighten the envelope but leave natural draft appliances in place, you risk backdrafting carbon monoxide into the unit. For these retrofits, we recommend moving to sealed combustion or electric appliances. So before we seal, we ensure the mechanicals are ready for a high-performance enclosure. Step three is the teardown. But notice we aren't gutting the place. This is surgical. We're doing this during a turnover, which is the ideal time. We pull baseboards and carpet. We remove window trim if there's leakage, and we'll pull the range hood to expose penetrations. We'll also expose basement headers and remove lighting fixtures. We are doing just enough to expose the root causes of the air leakage without rewriting the floor plan. Step 4 is where the work starts, sealing any large leakage points. This is a manual process that requires the right sealing details for each large source of air leakage. We cement the holes left by old vents. We spray foam the basement headers, including the shared header between units. We'll also latch and gasket the attic hatch, replace exhaust hoods with spring return dampers, foam or flash plumbing and drain penetrations, and seal the sump pit. This gets the building ready for the final seal. Step 5 is the game changer. We use AeroBarrier to seal all of the little leaks that manual labor simply can't find or reach. We cover finished surfaces and intentional openings. Then we pressurize the space and aerosolize the AeroBarrier sealant. It finds the leaks automatically while monitoring the leakage in real time. This bridges the gap between a pretty good renovation and a high performance outcome. We watch the leakage rate drop in real time on the monitor until we hit our target. Now a quick note, be sure to accommodate neighbors and be prepared to redirect migration with portable exhaust fans. Prep takes about a half day and cleanup takes about an hour once the seal is complete. Step 6, ventilation. When you get a building this tight, you have to control the fresh air. We install an energy recovery ventilator to provide a constant source of fresh, tempered air. We use units with auto balancing control to ensure we always have a balanced air exchange. This changes the building from one that breathes through dirty wall cavities to one that breathes through a filtered, controlled system. In homes with existing forced air distribution, interlock with your existing forced air furnace.
Finally, step 7, the test out. We run a final blower door test to verify the work. The data from this project is clear. We achieved airtightness levels in a retrofit scenario that are better than new construction. In fact, in all these units, we achieved an ENERGY STAR or net zero level of performance without the extensive gutting that is typically required. Thanks to our funding partners and the independent verification of Building Knowledge Canada, we've shown there's a scalable way to upgrade the building envelopes in low-rise housing stock. And it's not just about energy efficiency, it's just as much about durability and health. And now we have the process to deliver it.